So we need to find out the diameter of the sun in kilometers when its distance from the earth is given and its diameter subtends an angle of 32 arc minutes at the eye of the observer. So let's try to understand it graphically first. So here we have, let's say this is the sun and its diameter is represented by AB. Now actually AB is going to be curved in nature, but since the sun is quite huge, we'll consider AB to be a straight line. Now we have an observer here on earth represented by E, such that the sun is subtending an angle of 32 arc minutes on the observer's eye. Okay, and also it's given here that the sun is at a distance of 91 times 10 raised to the power of 6 kilometers, which we can consider to be the radius EB. So it is 91 times 10 raised to the power of 6 kilometers. So here we can use the fact that theta, which is the angle subtended at the observer's eye, so that's given by the arc length. Now our arc length will be nothing but the diameter of the sun divided by the radius, which is going to be the distance. So here we have 32 minutes. That's equals to arc length. That's nothing but the diameter, which we'll need to find out. And the radius is given as 91 times 10 raised to the power of 6 kilometers. The D must be equals to 91 times 10 raised to the power of 6 kilometers multiplied to 32 minutes. Now, in order to further proceed with the calculation, our goal will be to convert 32 minutes to radian. So let's do that. First, what we'll do, we'll convert our minutes to degrees. We know that in 60 minutes, so that corresponds to 1 degree. So that means 1 minute is going to correspond to 1 over 60 degrees. Now in our case, we have 32 minutes. So 32 minutes corresponds to 32 over 60 degrees. Or we can simplify it to get 8 over 15 degrees. Now that we have in degrees, we can convert it to radians, because we know that 180 degree corresponds to pi radians. So 1 degree would correspond to pi over 180 radians. So 8 over 15 degree, that corresponds to 8 pi over 15 times 180. So this is going to be in radians, or simply 2 pi over 675 radians. So we'll substitute this value here. So we have 91 times 10 raised to the power of 6 kilometers multiplied to 2 times pi. So pi we can take as 22 over 7 divided by 675 times 7. And when we solve for this, we're going to get the value 847,407 kilometers approximately. So this is going to be the diameter of the sun.